Here we have a supplementary video for lesson 19. Lesson 19 being about polar coordinates. So let's start from the very beginning and consider some questions. So what are polar coordinates? I guess any kind of coordinates for anything are just how you find the point. So of all the different kinds of coordinates there are, they're just ways to find points in space. All right. So for polar coordinates, we have r and theta, the two things you need, being a standard angle for theta. Right there, you rotate from the positive x-axis. If you were to rotate counterclockwise, the angle would be positive. If you were to rotate clockwise, it'd be negative. It's your standard angle. There's really not much else to say about the theta. So say you rotate, and if you rotate, you're then looking in a certain direction. So if I give you theta and I rotate by the angle, I can see anything that's out in this direction. And in that direction, r is the distance that you go to get to the point. Okay. All right. Cat's in the way. Pardon me. Anyway, so you go out the radial distance in the direction and you find the point. So I think if you can see it in the diagram, it's fairly simple. Okay, so we are not used to polar coordinates. Normally we use rectangular coordinates. Rectangular coordinates are just x and y. And how would they all be connected? Does x and y have anything to do with r and theta? Well, I can find the same point with x and y by going right however far I need to, and that would be the x. And then I would go up however far I need to, and that would be the y. Okay, so they're all connected in this picture, and apparently the connection is that triangle. So we can get some standard conversion. So if we ever needed to convert from one kind of coordinate to another, it's all right here. So what would be true about that? We would say that, first of all, x squared plus y squared was r squared, because that's a right triangle, and that's how right triangles work. But if you use cosine and sine and tangent, you can get other things. Cosine of that angle is x over r, sine is y over r, and you can connect them together like that. So we might say, in addition, x will be r cosine theta. I said cosine would be x over r, but then I wrote this down because I want it to look like on that side you get your polar coordinates, and on this side you get the rectangular, so you can convert from one to the other. Y will be r sine theta. And I guess we could say, what's one more? Tangent of theta is y over x. And, well, we could keep going, but I'm not so sure there's a point to writing any more than this down. So that's what I want to give you, okay? So that's what polar coordinates look like. These are the conversions. We either use these in their exact form, or maybe we modify them for our needs, whatever our needs are. Okay, so example then. Can you plot that point just to prove that you understand what polar coordinates look like? And then can you convert it to rectangular coordinates? So I think if you're going to learn this, why not use a protractor and measure the angles and make it look just right? Why not? Okay, so 140 degrees. I gave that in degrees just to make it simple. Could we give this in radians? Sure, we can, but I don't know that there's a point right now. So if I establish that, then this point must be in that direction somewhere. Okay? All right. So I like to start with the angle if I'm doing this. It seems to make the most sense that way. So say that I've established my direction is out there, and I go out a distance of 1.5. 1.5, whatever your scale is, and I don't know, I have this ruler here, so why not say the scale is by inches, and it's 1.5 inches, and I get to there. See, in that direction, I've got to go 1.5, however you measure things. And then you're looking at it, and I get this point right here. Okay, so there it is. All right, that point, 1.5 for r, 140 degrees for theta. Now I suppose that, you know, if I put the degrees there, you know it's a polar point because that's obviously an angle. But, you know, sometimes it's nice to say that, remember, that's r and theta, not x and y. Okay, so there's the plot. The point is right there on the graph. Next thing, can you convert to rectangular coordinates? Well, there's got to be an answer that you go so far left and you go so far up. And you're there. And that's x and y. That's what the rectangular coordinates are. So how about this? Let's use some variation of this as we see fit. I want to know that, and I want to know this being sides of a right triangle. Let's just always use the triangle. How about that? You have a point in polar coordinates, you'll get that triangle. What's this angle? That's 40 degrees. So we can do things based on that. We can say this triangle here will be true. Sine of 40 is y over 1.5. Okay. And that makes y is equal to 1.5 sine 40. What's that number? Well, that's how far up you go to get there. How far left you go? Well, I haven't done that yet, but how far up you go to get there, right here, that's whatever 1.5 sine 40 is. If you do something like this with cosine for the x, you'll get x is equal to 1.5 cosine 40. Okay, so I could give you the point like that. I can say this is x, that's y. But how about this? For my answer, I'm going to actually, let's do the math. 1.5, my calculator's in degrees, sine 40 degrees. So that's going to be about 1, almost 1. Let's say 0.96. And 1.5 cosine 40. So that's about 1.14, a little bit more than 1. Let's say 1.15. Alright, that's how I like to do math. I'd like that was the truth and that I could prove it by measuring it. I could see it. I don't know, I like to do things that way. So let's see. I did draw this to scale. So I am curious. And how far left do you go? Look, there's 1 inch to there, a little bit past 1 inch. Yeah, what do we find? 1.15. And then how far up do you go? So it says it's a little bit less than an inch. So let's see, put this right there. That would be an inch. It is a little bit less, so that certainly looks right if you go measuring it. But, okay, I did the math there based on that triangle. And, of course, you go left. It's not 1.15, you go left 1.15. So let's give the answer like this. We need to take the opposite of that. And so we'll say negative 1.15 for x. And 0.96, that's positive for y. So that's the way I would do it. I'll just use the triangle with the angle, and then I'll adjust the signs to take me in the direction I need to go.